All right, hello Algebra 1 honors. This is the second part of our 1.4 solving absolute value equations notes. And the last example that we looked at involved us having to isolate or get the absolute value brackets alone first before writing our two possible equations, okay? Now, today we're going to focus on some of the kind of stranger things that can happen when you're solving absolute value equations. So let's just dive right in to an example. Let's look at an absolute value bracket that has 2m plus 5, and then it's equal to, get this, another absolute value bracket. Now, there's a couple of things about this problem that put me on my toes and make me a little cautious. And one of those things is we're going to have the variables in two different places. And so there's a possibility we may get no solution or infinitely many solutions. So that's a possibility. But also it's a little bit scary having two sets of absolute value brackets. It turns out you still only have to write two equations. So that's the nice thing about it. You might kind of think, oh, I got to make one thing negative, one thing positive, the other thing positive, one thing negative, and just all these different combinations. Nope. As long as you just do two equations with one side being positive and then one side being negative, it will cover all the possibilities. So go ahead and write 2m plus 5 equals m. And then I'm going to choose to make the m side the opposite. So 2m plus 5 equals negative m. And go ahead and solve these out. When you've got m's on opposite sides of the equation, you want to get them together. I'm going to go ahead and subtract the 2m over this way. That way I avoid having 0. It just might save me a little bit of time. 1m minus 2m is negative 1m. And then divide by negative 1, we get m is equal to a negative 5. On the other side, I'll do the same sort of thing. I'll go ahead and move the 2m, do the subtraction property of equality. We get 5 equals negative 3m. Divide by negative 3. And you might think, oh no, I get a decimal. No, don't do the decimal. Just write it as negative 5 over 3. So we got two solutions. Not bad. All right, let's try another one that involves two sets of absolute value brackets, okay? This one's a little more complicated. Absolute value bracket 5k plus 12 equals 2 times the absolute value bracket 4k minus 1. Well, before we write our two equations, we always want to make sure that the absolute value bracket is by itself. Now, we've got two absolute value brackets here. As long as one of them is by itself, you can go ahead and write the two possibilities. Now, it gets kind of weird on this one. So one of the equations is going to be 5, whoops, my pencil's acting funny. I think it's running out of lead. There we go. 5k plus 12 equals, but we're getting rid of the absolute value brackets by writing the two possibilities of positive or negative. So what we do is we've got to remember that absolute value bracket acts as a grouping symbol. So to get rid of the absolute value part, we just change it back, or change it to parentheses like so. Now we also have to write our other equation, don't we? I don't know why I'm scrunching up here on the paper. So our other equation is going to be 5k plus 12 equals negative 2 parentheses 4k minus 1. Now, because the 2 and the parentheses are multiplying, I just need to put the negative out front with the 2, and that covers everything. If it was negative 2, or if it was 2 plus something, then I'd have to, distribute the negative, I should say. All right, let's solve these, see what we get. 5k plus 12 equals, I'll go ahead and distribute that, get 8k minus 2. Let's get those k's together. I'll do the subtraction property of equality to get 3k here. I'll do the addition property of equality to get 14 here. Oh, sorry, I'm looking at something. There we go, yeah. Divide by 3, don't panic, just leave it as 14 over 3. Like so. I do want to emphasize you should simplify fractions. For example, if it was like 14 over 4, you could simplify the fraction, divide numerator and denominator by 2. But improper fractions, as long as they're simplified, are a-okay. So 14 over 3 is great. And then we go and solve our other equation. 5k plus 12 equals, distribute it, negative 8k plus 2. Addition property of equality. Subtraction property of equality. Divide, division property of equality. And we get 2 solutions. Now, oh my gosh, I can't believe I haven't talked about this. You totally can check your answers here, right? So that's a good thing to remember on tests and quizzes. If you're done and you've got time, go back and substitute these back in and see that they work out, okay? There's a little bit of fraction work that you gotta deal with, but it's not gonna be too horrible. Plus, that's good practice. For the sake of having notes that are not too incredibly long, I'll let you do that if you so desire. Okay, so moving right along, check out this equation here. Absolute value 3n plus 18 equals negative 6n. Well, I'll be honest with you. I'm familiar with absolute value equations, and this one makes me especially nervous. And I'll tell you why here in a little bit. But we should already be a little bit nervous because we have an n on both sides. So we could get no solution. We could get infinitely many solutions. But also something that might be concerning is, are a lot of you saying, hey, wait a second, absolute value bracket equal to a negative, no solution, because we've learned that you can do that, because that's impossible. But with us not knowing what n is, n could be a negative number, in which case, when you multiply it with the negative 6, it'd be positive. So we get to solve this one using 2 equations, just like before. And then 3n plus 18 equals the opposite, so it'd be 6n. And we go ahead and solve these. I guess I'll subtract the 3n over. Subtraction property of equality. Divide. And let's go over here to the other side. Yeah, subtraction property of equality. Divide. And everything looks hunky-dory. But remember how I was saying about over here, this can't be negative? Let's check real quick. If I put a negative 2 in here, I'll get positive 12. So that should work out. And actually, I can do the math over here pretty quick and get positive 12 as well. So this one checks out. This is a good answer right here. N is equal to negative 2 solves it. But check out 6. 6 times negative 6 is negative 36. Can an absolute value bracket ever equal a negative 36? No. So what you've just been exposed to is something called an extraneous solution. So let's talk about it. An extraneous solution, and actually I guess, I don't know, I guess I won't write it down, but we can talk about it. An extraneous solution is an apparent answer that does not satisfy the original equation. And this is actually a fairly common thing in mathematics. This may be your first exposure to it, though. So basically, you do what you think you should do. And then you come to find out when you solve it, or when you check it, I should say, it doesn't work. So it's an extraneous solution. Now you want to be really purposeful with extraneous solutions. See how I X'd it out? I need you to do that. I want you to circle your answer or box it in like I'm a fan of, and then X out the extraneous one. The extraneous one is not a solution. It does not work. So there's something fun is extraneous. Let me write that out just because you might not be familiar with that. Extraneous solutions. So fun stuff. Now, I guess since we've already talked about it, it turns out that what caused me to know that an extraneous solution was possible was the fact that we had a variable in the bracket and a variable outside of the bracket. So that introduces the possibility of extraneous solution. So that's what you can be wary of. All right, let's try another one. Let's try, this one's kind of fun. Let's try absolute value bracket 2r minus 4 equals absolute value bracket 2r plus 10. Write your two equations. Now be careful here, because when we want to make it, whoops, let me change that. When we want to make 2r plus 10, it's opposite. Because we have 2r and we have plus 10, we've got to distribute the negative. Like so. So distribute the negative. If all we had were two things multiplying like up above, you just got to put it with the one up front. It will naturally distribute later, right? But when you have addition problem, and so there's multiplication, but there's also addition, you want to go ahead and distribute that negative. Let's solve this. Oh, something funny happens, doesn't it? Subtract 2r, gone. We get negative 4 equals 10. So it turns out this is no solution, but it was no solution from this equation. So we just ignore it. We still have our other equation, which we can do the addition property of equality. Addition property of equality. And we get a nice fraction answer of negative 6 over 4. Is that a good final answer? We can simplify this, can't we? The 6 has a 2 as a factor, the 4 has a 2 as a factor, the 2's will divide out to make 1. So what we actually have is negative 3 halves as our solution. Now this wasn't an extraneous solution. This was just no solution, right? That was no solution. This one got us a solution. All right, and one more just for good measure. 3 minus absolute value bracket x plus 4 equals negative 7. Are we ready to write two equations? No, we must isolate the absolute value bracket before writing our two equations. I've noticed a little bit of issues with this this year. This 3, if you're not sure whether to divide 3, subtract 3, add 3, do something for me real quick. This minus sign right here, write plus a negative. Add the opposite. Now I feel like it's a little clearer to see that to undo this 3, what are we going to have to do? That's right, we're going to have to subtract a 3. Now, how do we undo multiplying by a negative? We can divide by a negative on both sides. And when you divide by a negative on both sides, you'll get absolute value bracket x plus 4 equals 10. Write your two equations. because what's inside the absolute value bracket could be 10 or it could be negative 10. You solve it and you get 2 solutions, just like that. So that's just a reminder that you need to isolate the absolute value bracket. Okay, so the practice for this is page 32, numbers 1 through 21, every other odd, but then also numbers 35, 37, 40, and 42. So this is the entire 1.4 assignment. All right, thanks so much for watching. Have a great day.